Hey everybody, in this video we're going to look at serialization techniques of elements other than pitch. So let's dig in. Let's begin by looking at this piece by the American composer Milton Babbitt, who was a music professor at Princeton University and also a mathematics professor at Princeton University at various times in his career. This piece was written in 1947. So let's give it a quick listen. Okay, as we take a look at this piece, I've labeled all the rows for you. And at first glance, this seems like a pretty standard piece of dodecaphonic music. We've got the P0 row accompanied by P6, the RI1 row accompanied by R0, and the I7 row accompanied by the RI7 row, and so on and so on. We have these row presentations in linear fashion. But as we're going to see, there's a lot more here than meets the eye. In serialization of pitch, we typically have four forms of any given row: the prime form, the retrograde, the inversion, and the retrograde inversion. If we think about the notes on a clock face, we could think about the prime form as being the clockwise version of the notes, in which they would move through all 12 pitch classes, and then we would have to start over again with the same pitches because there's only 12 options, because enharmonics, remember, don't matter. We could assign every pitch a number and we would end up with 12 pitch classes. If we wanted to use the retrograde version of that row, we would simply go in the counterclockwise direction. If we wanted to find the inversion of some interval within the row, we would do the following process. For example, if note 1 to note 2 is 3 positions clockwise on the clock face, in other words, up 3 half steps, then to get its inversion, we would go counterclockwise down 3 half steps to get the inversion of that pitch. And these processes are used to create these permutations of the row. And then, of course, the retrograde inversion would be, once you get the inversion, you just take it backwards. But in this piece by Milton Babbitt, he's not only using serialization techniques for pitch, but he's also serializing the rhythm. And what he's done is created a random ordering of rhythmic proportions and called it his prime form of the rhythm. And his prime form of the rhythm is in a 5-1-4-2 rhythmic grouping of 16th notes. So if we think of a 5-note 16th note grouping, and then a 1 16th note grouping, and then a 4 16th note grouping, and then a 2 16th note grouping, we're going to end up with 12 16th notes, which is what it takes to fill a measure of 3/4 time. And this is the arrangement that Babbitt calls his prime form. So if this 5-1-4-2 grouping of rhythms is a prime form of serializing rhythm, then the retrograde would obviously be the backwards version of that, the 2-4-1-5. But the real question becomes, how do you create an inversion of rhythm when we're not dealing with pitch? And what Babbitt has done is created a similar wheel to this. This would be called a mod 12 system, because there are 12 units on the wheel before you start repeating. What he did was create a mod 6 wheel in which we would have 6 on the top, 3 on the bottom, 1 and 2 on that side, and 4 and 5 on that side. In this clock face, in order to get to the number 5, you have to move 1 position to the left or counterclockwise on the clock face. So the inversion of that would be to move clockwise 1 position on the clock face. So if we're going to find the inversion of 5142, we're going to have to do each number and take the inversion of it on the clock face. So the inversion of 5142 is the inversion of 5 is 1, so you go the opposite way. The inversion of 1, which is 1 position clockwise, would be 1 position counterclockwise. It would be 5. The inversion of 4, which is 2 positions counterclockwise, would be 2 positions clockwise. And the inversion of 2, which is 2 positions clockwise, is going to be 2 positions counterclockwise. So this is going to be the rhythmic grouping for the inversion. And of course the retrograde inversion would be the opposite of that, read from right to left, which is 4, 2, 5, 1. And what Babbitt is going to do is he's going to use these rhythmic groupings for the prime form rows, and he's going to use this rhythmic grouping for the retrograde pitch rows, and any inversion rows of pitch he's going to use the 1, 5, 2, 4 grouping, and for the retrograde inversion pitch rows he's going to apply this rhythmic grouping of 4, 2, 5, 1. Okay, this chart shows the prime form of the pitch row along with the rhythmic serialization that Babbitt's going to apply. The prime form of each pitch row, and there are 2 in this piece, P0 and P6, so any prime form of the pitch row is going to be accompanied by the prime form of the serialization of the rhythm. So the rhythmic pattern of 5, 1, 4, 2 is going to accompany all of the prime forms of the pitch rows. And as discussed, the retrograde pitch row is going to be accompanied by the retrograde rhythm row, which is the backwards of the prime, 2, 4, 1, 5. And the inversion rhythm row is 1, 5, 2, 4. And the retrograde inversion is 4, 2, 5, 1, which will accompany all of the pitch rows of the same kind. Also notice that Babbitt has serialized not only the rhythm, but also the dynamics. So all the prime forms of the pitch row will be accompanied by the prime form of the rhythmic row, along with a mezzo piano dynamic. And the same is true of the retrograde rows will be mezzo forte, the inversion rows will be forte, the RI rows will be piano. So as we see these side by side, remember that the first P0 row was in this bottom staff, and so that means that we're going to apply a 5-note rhythmic grouping, a 1-note rhythmic grouping, a 4-note rhythmic grouping, and a 2-note rhythmic grouping. Now one thing to note here is that at the end of each of these groupings, often he will elongate the last note of the grouping, but you'll still get the 5, 1, 4, 2 grouping. The last note won't always be a 16th note, in other words. So first of all, we see this prime form is accompanied by the mezzo piano, and we have a 5-note grouping, a 1-note grouping, a 4-note grouping, and then a 2-note grouping of the serialization of the rhythm. This P0 row was accompanied up top pitch-wise by the P6 row, so we're going to apply the prime form of the rhythms again with a 5, 1, 4, 2, and also the mezzo piano marking. So we have a 5, a 1, a 4, and a 2. As we get to the next few measures, the top staff was an R0 row, so we're going to look for the mezzo forte marking, and it's going to be accompanied with the retrograde serialization of the rhythm, which is 2-4-1-5 pattern. So we see a 2 followed by a 4, and then a 1, and then a 5. And the R0 row was accompanied with RI1 originally in the pitch. And so this is going to be one of our 4-2-5-1 rhythm groupings. So, and also a piano dynamic. So we have a 4, 2, and then a 5, and a 1 rhythmic grouping. The next measure up top was an RI7, so we're going to be looking for a piano marking with a 4-2-5-1 rhythm grouping. And we have our piano marking. We have a 4, 2, then a 5, and then a 1. And this tone row was accompanied by I7. So rhythmically, we should have a forte marking, which we do, and then a 1-5-2-4. So we have a 1, and then a 5, and then a 2, and then a 4 rhythmic grouping. And in this last system, we had an I1 row on the top, so that should be a forte marking and a 1-5-2-4 rhythmic grouping, 1, 5, 2, 4, accompanied by an R6 row, which would be rhythmically a 2-4-1-5 grouping with a mezzo forte, 2, 4, 1, and 5. So we can see from looking at all of this that we have interwoven through this piece pitch serialization, which we saw on a different slide, accompanied by rhythmic serialization, and also integrated within is the dynamic serialization as well. As we saw in the Babbitt piece, composers at this time were serializing elements other than pitch, and in the Babbitt piece we saw the serialization of rhythm as well as dynamics. And around the same time that Babbitt was writing his piano pieces, the French composer Olivier Messiaen was writing this piece. And this is a chart that we have from this piece that explains what he was doing. And as you can see, there are 3 rows, and each row has a pitch set 12-tone row. But notice also that these are octave-specific pitches. These are not pitch classes. These are octave-specific pitches with also a duration attached. So we are serializing here pitch specific, and each pitch is attached to a specific rhythmic value. So we're serializing rhythm, pitch, and not only that, but each one of these notes is attached to a specific dynamic marking. So we have the same idea, but these dynamics are attached to single pitches. So the dynamic is going to change every time a new note arrives, unlike what we saw in the Babbitt. And a fourth element is introduced here, and that is the articulation. So we have now not only a serialization of pitch and rhythm and dynamic, but we also have a serialization of articulations. And as we can see here, as it's applied, it's loosely applied in the sense of the ordinals. If we trace the first one, for example, we see this note here, and then the D, and then the A, and then the so forth, which with all the accompanying elements, the articulation and the dynamic. But as far as the ordinals go, if we trace it across, we go 1, 2, 3, 4, 6, 5, 7, 10, 11, 12, 11, 8, 9. So they're kind of loosely applied in the sense of the ordinals, but each time the note does appear, it is attached to its articulation and its dynamic and its rhythmic value. So we can see each of these lines and how they can compare to the chart. Let's listen to this short excerpt to get a taste of what this piece sounds like. Pierre Boulez was a student of Olivier Messiaen, and in this piece, he uses the same row that his teacher did, the E flat D, A flat row, etc., with the same rhythmic values, although he does attach different articulations and dynamics. When the pitch, duration, articulations, and dynamics are all being serialized, this is referred to as total serialization, as each musical element that can be serialized is being serialized. We're not going to listen to this for time's sake, but feel free to pause the recording and examine this chart to understand all the serialization techniques that Boulez is applying. So in this video, we noted the manner in which various composers were serializing elements other than pitch in the mid-20th century and a few methods in which these techniques were applied. Having looked into some of this music a bit deeper, I hope that you will come away with a greater appreciation of the music and not view it as merely a random collection of pitches that were haphazardly thrown together. Instead, I hope you will see this music as carefully crafted by master composers who were seeking new ways to express themselves in a post-tonal world.